Hello Legacy Savers, Marsh here. So today we're going to look at reviewing slope and graphing. What are you going to have on you today? You're going to want your notes. You may want a calculator to do some simplification, and then also a pen or a pencil. So, learning targets. What do you need to be able to do by the end of this video? I can determine slope of a line three ways, basically using a graph, using a table, and given 2 points. I can graph a line using slope-intercept form, and I can algebraically determine if two lines are parallel, perpendicular, or neither. Slope of a line. Now, this is not new stuff. This is pretty old hat, but let's just make sure we know what we're doing here. Now, there's a couple ways that we have found slope. Either it's the steepness of the line as it rises or falls, that's what technically it is, or it's called the rate of change. So the change of the rise over the 1, usually you'll be hearing that, or change of y over change of x. That is the y2 minus y1 over x2 minus x1, if you remember doing that. Now, slopes can either be positive, negative, 0, or undefined. What do those look like? Well, these are the different kinds of slope we can have. First of all, that is a positive slope. Notice, guys, if you would think about if I have a car here, do you see how the car is going to go up the hill? That is because it is a positive slope. This one would be negative because I have a car that is going down. He's going to go down the slope. Now, here's the ones that students struggle the most with, is the horizontal line and the vertical line. Horizontal is a 0 line. It has 0 slope because I am running a whole bunch but not rising at all. So it'd be rise 0 over some number of running. Okay? Undefined is the vertical slope. That's up and down. Because it is number over 0, because you're rising, but you're not going over. Something to keep in mind. Now, 0 and undefined, those are the two that a lot of students struggle with. Try to keep those straight as you continue on your mathematical career. Now, let's go back further into geometry. Parallel lines. Those were lines that are in the same plane, but they never intersected. That's what makes them parallel, right? Perpendicular means that there are lines that intersect at perfect 90-degree right angles. So now, what does that actually mean in algebra? How can we determine if two lines are parallel or if they're perpendicular or neither? Well, parallel lines, guys. Here I have these two lines. I have one that's going right here to here, right? So we got a rise of 1, 2, 3, 4, and a run of 1, 2. So my slope for this line would be 4 over 2 or just 2. Let's see what this one's got. We have a dot right here, and it looks like a dot right here. So I go up 1, 2 over 1. So my slope would be 2. Notice, guys, they are the same. So the slopes, they are the same. No change. Same slopes. Perpendicular. Let's see what these guys do. So I got one right here, one right here. So down 1 over 2. So that's negative 1/2. This one, we go here to here. So if I go up 2 over 1. Notice that is 2 over 1. Now, slopes. How do you put this into words for perpendicular? They are opposite reciprocals of one another. Notice how they are different signs. That means the opposite part. So one's positive, one's negative, and then they are flipped. That's what the reciprocal means. So, if two lines are parallel, the slopes are going to be the same. Perpendicular, negative reciprocals of each other. Negative and opposite depending on which way you want to say it. I usually will say opposite just because I think it's easier for you to think. Because if it's a negative, it's going to be a positive. So they're opposite reciprocals of each other. Now, let's actually look at an example. I have these two lines that go through these 2 points. I want to know, are these lines parallel, perpendicular, or neither? What do I need? I need slopes. So let's find some slope here. I have the point 3, 0 and negative 1, 2. That is located on line 1. So to find my slope, I'm going to do my y2 minus y1 over x2 minus x1. So 2 minus 0 over negative 1 minus 3. Notice, guys, how I just kind of labeled above. You can do that. If you don't need to, that's fine. I do it just so in case I forget which ones I used for the second point, which ones I used for the first point. 2 minus 0, that is 2. Negative 1 minus 3, that is negative 4. Now, you are going to want to make sure you definitely simplify your slopes. Otherwise, you might not see that they're parallel. So, I'm going to have negative 1/2, 2 over negative 4. Negative can just come up to the top. So then it would be 2 over 4, which is just a half. Let's check this one out now. I got x1, y1, x2, y2. So I got 4 minus 0 over 3 minus 1. So 4 over 3 minus 1, 2. That is just 2. Notice, guys, so are they parallel? Parallel meaning they are the same slope. No, not the same. Perpendicular. That means that they are opposite reciprocals of one another. So I notice that they are different signs. 1 check mark there. And they are reciprocals of one another because that 1 over 2 would become 2 over 1, right? If you think it that way. So I'm going to have negative 1/2 and 2 over 1. Thus, these two lines are perpendicular to one another. Now, what does it mean to be a linear equation, or a linear function for that matter? Well, this is an equation that uses x and y, but also graphs into a straight line. Now, here's a couple of examples. Notice, guys, it doesn't just need to be equal to y. They need to have an x and a y, but neither of them can have an exponent. So there is no exponent located on the x or the y. Technically, there's that 1 there, but it's not a squared or a cubed or anything funky like that. Now, what does it mean to be a solution to a linear equation? What that means, there is a point, xy, that works in the equation and makes the equation true. So, is the point 5, 4 a solution to the equation y equals 2x minus 6? What we're going to need to do is plug this in for x and for y. So I'm going to have 4, because that's my y term, right? 2 times my x, which is 5, minus 6. So I got 4 equals 2 times 5, that's 10, minus 6. So 4 equals 4. That is true. Thus, this is a solution. It is a solution. Now, how many solutions are actually located on a linear function? Well, that is actually infinite, because if I graph a linear function, it is the collection of all the points that are solutions. X values being their domain, y values being the range. So if I have this dots here, if I start putting some dots in here, ultimately, guys, these are all going to be solutions to an equation that would run like this. So all of those would be points on my graph, and all of those being solutions to the equation of that particular line. Now, let's remember back, what is slope-intercept form? What is that? What did it look like? A lot of students, they'll scream out y equals mx plus b whenever you think of a linear equation, which is really good. That is exactly the most common form of a linear equation, where m is your slope and b is your y-intercept. Now, you probably remember that from a long time ago. That is why it's called the slope-intercept intercept form because it has both a slope and the y-intercept. Now, slope in M, I'm not really sure why, and I'm not sure why B is the y-intercept. Never really found out why those two letters are consistently used. However, you will see that written consistently across the board, the M and the B for your slope and your y-intercept. Now, let's do some remembering of how to graph using y equals mx plus b. Well, very first thing I notice is I have a literal equation here. It is not solved for y. That is not good. Can't graph without being solved for y using y equals mx plus b form. Alright, so first thing I'm going to do, I'm going to subtract 3x from both sides. I want to get y alone. So, I'm going to get 2y equals negative 3x plus 4. Now, let's divide by 2. So I'll get y equals, to make this look nice, I am going to divide this 2 into both of them. So I'll have negative 3 over 2x plus 4 over 2. Ultimately, if I simplify here, negative 3 halves x plus 4 divided by 2 being 2. Now, how do you graph using y equals mx plus b? First things first. Plot your y-intercept. Whoa, my pen's a little weird today. So my y-intercept, remember guys, is our b value, 2. Since it's the y-intercept, that is where it's going to hit on the y-axis, right? So I'm going to mark a dot at 2. Then we are going to use our slope to find new points. So I am going to go down 3, right 2. Now that negative could also allow you to go left 2. I try not to use that due to the fact it's harder for me to make sure I'm going the right way. So I always associate the negative with a down. That way I can get one part of the graph done and then I can just kind of mirror the other side. So I'm going to go down 3, 1, 2, 3, over 2, 1, 2. Down 3, 1, 2, 3, over 2. And so on and so forth. Then I can go up 3, over 2. Notice, guys, how it's in just a pattern. And then I'm going to connect my dots to the best of my ability. Ooh, that's not too bad. Notice, guys, though, how I am putting arrows on both ends. This is a line. Please, 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 lines go on forever. Linear equations do. So, please make sure that there is arrowheads on both sides of your equation. Otherwise, you're saying that this is a line segment, and that is not a function. So please, 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 on any graph you do, please make sure some arrowheads get placed on that line. Alright? And that's the end of this video. See you later, Sabers.